Okay. Good morning. So let's start with that. Start with the course. That first class we have explained that introduction of the speech processing that things, and second class recording part. Now let's start with the human speech production and its source filter modeling. So since the objective is to model the human speech production system, so let's describe what is human speech production model and how it can be you can say synthesized using the source filter model. So as we explained that human speech production systems depends on some steps. First one is the message planning that involve the linguistics parameter, then role of prosody, the utterance planning, then the psychological constraint by the motor command generation, then speech sound production and radiation of the speech from the mouth. Okay. Now, if you record a speech and if you just display the speech, it will look like this. If you see here, this portion I have not spoken anything. This portion I started spoken, this is called unvoiced sound, some noisy sound may be there, then there is a voice sound is generated. So normally in speech I can three part, one is silence, one is voice, unvoiced, another one is a voiced. So silence means when I am not taking anything, nothing is coming out from the mouth, is the silence part. Then there may be a unvoiced, aspiration will be there or friction will be there, and there will be voice sound. Now how do I produce this kind of sound, and how do I, what is the meaning, how when I communicate a message, what kind of different voice sound and different silence and different unvoiced sounds I have produced, that you have to know that things. So that is the speech production system, how the different kind of sound is produced by the human being. Now if you take the basic definition, somebody will ask you what is speech? What is speech? Speech is a composed of a sequence of sound. Speech is nothing but a sound. Speech is not signal or not kind of things. So human being use speech to communicate message from one person to another person. Okay. So it may be transmitted to electronics media on what kind of, that is different business. So speech is a composed of a sequence of sound which is produced by the human vocal cords. Now once I say sound, what is sound? What kinds of sound? Sounds or phonemes serve as a symbolic representation of information to share between human beings. If I say I want to communicate a message from one human being to another human being, or human being to machine, or machine to machine, in that case what I required, the speech is a composition of different sounds. Now what is sound? Sound serve as a symbolic representation of information which I want to communicate. That information has to be symbolically represented so that it can understand by the listeners. Okay. So arrangement of sound or phoneme, sound is called phoneme, basic unit of sound is called phoneme, and it should be not haphazardly arranged. It should be arranged in a some specific manner which governed by the language rule, so that listeners can understand. Suppose if I say Kolkata, Kolkata, if I say Kolkata, there is a sound Kolka, ko, o, lo, ko, a, ta, to and a. All the sounds are there. So ko is a sound, o is a sound, then lo is a sound, kul, ka, again ko is a sound, then again a is a sound, then again to is a sound, then again a is a sound. So if those sounds are pronounced or composed in a sequence, so that then a message that I am saying Kolkata is transmitted from talker to listeners, and those composition of sounds are governed by the language rule. I cannot compose okay, lo, then ko. Any arbitrary composition will not make any sense, although individual sound has a sense. And this composition is governed by the language rule. Okay. If I say Japanese, Chinese, suppose I do not know Chinese. If some speaker spoken Chinese, he is speaking the sounds in a some composition. Maybe some of the sound I know, but I do not intend or I cannot identify the intended message he want to communicate, because we do not know the language rule by which the sequence of sounds are arranged, that is linguistics. So, linguistics is the study of the rule of those rule. How do I human being produce different sequence of sound to communicate different kinds of message? There may be different kind of things, different kind of, you can say the different kind of rules are applicable for rules may vary from language to language. So, discipline which study those things is called linguistics. Then how the different sound is produced or study of the individual sounds is called phonetics. Suppose ko, this is individual sound. So, sound of individual sounds, that study is called phonetics. How the sounds are governed by the rule, language rule for making the valid composition is the study of language, that is called linguistics. Here I am explain the details of the phonetics. So, phonetics is a sound, so it is produced by a human being in acoustics waveform. So, I will cover the acoustics phonetics and articulatory phonetics. Once the sound is coming in the air, it is the acoustics. So, I have to know the acoustics part of the phonetics and how we produce the different sound using this vocal tract is the articulatory phonetics. So, the phonetics has a two part, one is called acoustics phonetics, another is called articulatory phonetics. So, I will details cover those things, because we have to understand the sound, but composition of sound is the study of linguistics. So, there may be a phonology, there may be a language rule, grammar, and there may be a some kind of arrangement, pragmatic, paralinguistics, linguistics, all kinds of rules will be there. Okay. Now, let us look how the human vocal tract look like. This is the X-ray of human vocal, this whole systems X-ray, whole systems. There is a vocal cords and there is a tube, articulatory tube. Whole system X-ray is look like this. If I take the MRI, this is taken from Professor Srinarayan. So, if you see that MRI of the human vocal tract which look like this, this is the lip, then there is a tongue whose tip of the tongue is open, back portion is closed, then there will be a vocal cord here. So, if I schematically represent this thing, it will look like lip, then tongue, tip of the tongue is open and back the bottom is closed, bottom is fixed with the lower jaw, then this is the palate, then there is a velum, because we have a nasal cavity and we have a oral cavity. So, velum may be closed or velum may be open, then there will be a pharyngeal walls, this then there will be a glottis section. Okay. Now, if I take the schematic representation of the speech production system, it will look like this. How the speech is produced by human being, this is schematic representation. So, there is a lungs. So, what is the source of the sound? If we see, forget about the speech, basic source of sound is nothing but a vibration. If I want to generate a sound, sound is nothing but a mechanical oscillation. So, it is nothing but a mechanical oscillation. So, a mechanical body is vibrating and sound is acoustics wave is generated. Okay. Now, vibration of mechanical body required external force. I require a force to vibrate the body. Okay. Now, if you see, if I have a membrane, connect a membrane, if I pass the air, very thin membrane is closed, and if I pass air in force, the membrane will vibrate and sound will be produced. In childhood, if you see the kite which is flying in the sky and there is some membrane is attached and membrane is vibrating in the air and producing a sound. this childhood in India people are used that things. So, there is a source of, you can say the source, external force is required. So, during the speech production, the lungs, when I take the air, inhale, and I gradually exerted that air and produce different sound by constructing the different location of the tube. Okay. So, lungs produce or give the air pressure which is required to the production of sound. So, this is the force, and once this lungs press the air to upwards, there is a vocal cords. So, vocal cords are generally open when you take inhale. If I want to speak something, the vocal cords has to be closed. If it is open, no sound. So, there is no sound is coming from the mouth. So, if it is vocal cord is closed, then when the air is passing through the vocal cords, it is a membrane, and if the membrane is exposed to a high velocity of air, so that creates that vibration in the membrane. So, that vibration cause the sound and pass through the cavity. Now, if I say tongue, we have a tongue. Tongue separate the cavity in two parts, one is called back cavity, one is the front cavity. Okay? And we have a velum. If you see the velum, either velum can be closed or velum can be open. If velum is open and oral cavity is closed, then the air will passes through the nose. So, nasal cavity is involved. If the velum is closed, the sound is only passed through the mouth, that is called oral cavity. So, if there is that's a two kind of sound, either velum may be closed or open. If velum is open, then the sounds become nasal, because nasal cavity is involved. If the velum is open, closed, then nasal cavity is distract from the cavity, then it is called oral sound. So, the sound is produced using this mechanism. Lungs create the pressure, pressure goes upward. If the vocal cords are closed, then the vibration will produce, and that vibration create the sound, and that sound is modified depending on the tube structure when it passes through the tube. Okay. So, I can say in human speech production system has a two part, one is the source, here the source of sound is vocal cords, okay, and lungs only they provide the pressure. So, one is the source, and once the sound is produced, that source is passes through the cavity, or you can the tube, this tube, and it's modified to create the different kinds of sound. Once its source create the sound, when it passes through the cavity, depending on the structure of this tube, it's modified and it produce different kinds of sound. So, I have a source and I have a tube. This is the two part of the sound production. So, now goes to the source. What is vocal cords? How it is look like? If you see, the vocal cords is look like this picture. Now, if you see that air is coming from the lungs, if the vocal cord is closed, then the airflow will be obstructed, and the velocity of the air will be different, because air pressure in here will be increased and air pressure will be decreased. Once it is little bit of open, the air will passes through these vocal cords and create the vibration. Okay. So, that is the sound. This is the original picture, or you can say that the endoscopy picture of the vocal cord. This is the closed position of the vocal cord, this is the open position of the vocal cord. So, this is the vocal cord structures, this is the closed position, this is the open position. Now, if you see the vocal cords is closed, it is not like this thyroid movement. One end of the vocal cord is always fixed and it is closed and open in the other end, okay, and that create the sound. So, now if I take the schematic structure of this will look like this. So, different cartilage and close this either. So, movement of the vocal cords depend on the muscle movement. Okay. Now, one end is closed, this end vocal cord is closed and this end is the back end is open. Okay. Now, once either it can be closed either or it will be totally open. So, there is no sound breathing. If it is closed, voiced. If it is slightly, if it is open, but the tube can produce a noise kind of sound, that is called unvoiced sound. Okay. So, unvoiced, voiced and silence region I have seen in the first slides in here. Now, if I see the glottal flow, how the air is flow in the glottis. So, once the vocal cord is closed, if the vocal cord is closed, no air can flow. So, either it is gradually open and closed, open and closed, open and closed. Once is closed, air flow stopped. Once is gradually open, one flow increases, 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 and again this decreases, decreases. So, I can say this is the flow diagram. Air flow is increases, 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 and again decreases and close phase. Again it is open and again it is closed. Okay. So, I can say either complete open to open is a period or close to close is a period. Okay. And if I take the difference of the flow which create, so difference of the flow will create the sound vibration. So, differentiate, if I differentiate this thing, it will be look like this, which create the vocal cord vibration. So, this is the differentiation of the flow. Now, if you see that this tip to this tip is a period. Okay. Either close to close is a period or open to open is a period. Okay. So, this is source. I can show you the diagram in here. This is called engineering model of the source. So, what is the engineering model? If you see, this is the lungs. Okay. Now, vocal cords, any mechanical vibration is not, any sound, production of the sound is nothing but a mechanical vibration. So, what is the form of a mechanical oscillator? There is a spring, there is a mass and there is a mechanical damping. This is the mass, this is the spring constant S and this is the mechanical damping Rm. Okay. So, air act as a force on this mechanical oscillation. So, I can say two vocal cords can be act as a mechanical oscillator and that oscillate by the force which is coming from the lungs. Okay. And that is UG. If you see the UG, mechanical oscillation produce the acoustics wave. So, acoustics wave has a volume velocity and is a pressure wave, it has a volume velocity. Okay. So, it is a volume velocity UG, particle velocity, and from you can multiply for fixed unit, fixed volume, this is a volume velocity. Okay. Now, UG is the air flow velocity, volume velocity will come through this different vocal tract shape. Okay. So, now, if you see the whole tract, the source is nothing but a mechanical oscillator, it creates the vibration. Once it create mechanical oscillator, it create the vibration, it has create the vibration is term of impulse. So, source can be modeled using a impulse source. Okay. Now, this has to be passes through this tube, this is a tube. Now, tube can form different structure using the tongue, lip and velum movement. Okay. Now, if you see, I can move the tongue in upward, I can back of the tongue can be raised, tongue tip can be touches in the upper palate. So, when we speak, if you see the upper palate is fixed, lower palate the upper portion is fixed, upper palate is fixed. Now, in lower portion, lower jaw, upper jaw is fixed and lower jaw is moving, if you see. So, I can move the either lip, I can close the lip, I can open the lip, or I can move the tongue to divide the cavity in different structures. So, I can say when this vibration passes through a different kinds of tube structure can produce different kind of sound, cascading tube. So, if I consider that things, then I can say this is the source of the sound production and that source sound is passes to the different structure of the cavity and different time to produce the different kind of sound sequence. So, I can say that source is a impulse response that can be passes through a filter. Depending on the filter structures, different sound can be generated. So, in engineering model or human production system, if I see it is a source filter model. So, vocal cord is producing the source, which is nothing but a impulse, either sound is present or sound is absent. Either source can be present or source can be absent. Then it is passes through a filter. This is time varying filter. Different time structure of the tube will be different to produce different kind of sound. Let us this is SN or this is speech. Okay. So, digital circuits I will come later on. So, I can say whole human speech production system can be modeled using a source filter model. So, in I can say I can study the source or I can study the filter, combine the both, I will get the speech. Okay. So, who produce different kind of sound depending on the structure of the filter? Source, either source vocal cord can vibrate or vocal cord without vibration. So, either source can be present, that is called voice sound, either source can be absent, that is called unvoiced sound, or voice sound when it is produced and it pass through the filter, it can produce the different kind of voice sound, different kind of voice speech. Okay. Now, if I see the I will come this one again, I will come when I talk about the tube modeling, but here I will explain. So, excitation, so impulse is nothing but a excitation parameters, excitation is generated and that excitation part of the going to the linear time varying system filter and I get the speech. So, this filter I have to model, this excitation part I have to model. Okay. Now, if I say what are the properties of this source? If you see, if it is an impulse, then it has a period. Impulse is a period. So, which is the fundamental frequency of the source? Human being also has a fundamental frequency. The speech is a quasi periodic signal, it is not exactly periodic. So, human being also produce different kind of this source fundamental frequency depending on the requirement. When we speak, we never speak in a single fundamental frequency, that will become too mechanical to hearing. So, fundamental frequency are gradually moving to provide the melody on the speech. Think about singing. Filter produces a different sound for content purpose, but melody is defined by the source itself. If you singing, think about the singing, the control of the fundamental frequency, sa, re, ga, ma, all the notes are nothing but a movement of the fundamental frequency. So, those controlling of the fundamental frequency is generated by the source. So, movement of the vocal cords. I will discuss how this vocal cord movement, how the vocal cord produce different fundamental frequency by varying the tension of the vocal cord and position of the vocal cord. So, that is I will discuss in later class during the prosody modeling. So, movement of the vocal cord tension can change by two types, one is called forward and backward movement, one is vertical movement. So, if the source or fundamental frequency is the property, so fundamental frequency is the property of the source and filter responsible for producing different kind of sound. So, if you know the digital filter, how the digital filter is characterized? Depending on the frequency response. Okay. So, if I say the digital filter is represented by Hs, you know the Laplace transform Hs, or you can say the Hn, whatever, Hs represent the frequency response of the filter. So, if the frequency response of the filter is look like this, and the source is passing what the impulse response contain all the fundamental frequency, all the frequency, let us same height, and this is the, you can say, time, and this is the frequency. This is the frequency, and this is the power. This is the frequency, this is the power. So, as per the signal processing model, when the source is passes through a filter, source signal will convolve with the filter signal to produce the speech. In frequency domain, convolution is nothing but a multiplication. So, if I say in little bit of signal processing, if I apply here, if I say source is nothing but a ET and filter is nothing but a HT, okay. So, output speech is ST. So, ST is nothing but a HT convolve with ET, convolved with ET. If I take the Laplace transform in frequency domain or Z transform, let us take the Laplace transform, then SS Laplace domain is nothing but a HS multiplied by S. So, frequency response of the filter will be multiplied with the frequency response of the source and produce the speech. So, different sound is responsible by the filter, source is responsible, either there will be a voicing or there will be a no voicing, either there will be a voicing signal or there will be a no voicing. So, response, so this is nothing but a multiplication, okay. But source provide the fundamental frequency of the speech. So, in case of singing, when you say sa node, sa re gamma pa tha, so actually you are controlling the fundamental frequency of the vocal cords. So, the controlling of the fundamental frequency, which is, I will talk about the prosody modeling part, I will details mathematical explanation I will give in that how this fundamental frequency of the vocal cords can be changed. Now, if you see the singers are practicing in morning to touching up the some, or you can see the comment like that, you have your upper node is not that clear, lower node is clear. What is meaning? Meaning is that the changing of the fundamental frequency from lower to high or high to low. So, upper node and lower node, that changing or controlling of these vocal cords is important. So, you are practicing controlling of the vocal cords by riwaj, so that you can touch the perfect note. Okay. During the speaking also, we change this vocal cord fundamental frequency with respect to time to provide the melody on the speech. Okay. Now, some fact, if you see, so sound source and sound has a filter. So, the acoustics of male and female vowel differ reliably along two different dimensions. So, sound can be, this ST is depends on the source and depends on the filter. Source, if it is voice sound, source is exist and source provide the fundamental frequency, and filter modify that source and produce different voice sounds, that may be vowel or that may be a voice consonant also. Okay. So, it is not necessary it will be vowel, it may be a consonant, voice consonant also. So, for source modified by the filter producing different kind of sound. So, fundamental frequency or F0, sometimes we say pitch, F0 is sometimes defined as pitch, but pitch is a perceptual dimension parameter, F0 is the physical dimension of the parameter, F0 can be measured, but pitch is perceptual, pitch cannot be measured. Okay. So, F0 of the source depend on the source and different sounds which depend by the filter. So, if I say the human being, different kind human will have male versus female, male versus female. If you see F0 depend on the vocal cord length, vocal cord mass, those two things. If you see the vocal cord is close this end, if the length of the vocal cord is increases, what will happen? The fundamental frequency will be decreases. If the mass of the vocal cord is increases, fundamental frequency will be decreases. If you see the drum, huge membrane drum, mass length is increase, area is increases, fundamental frequency is decreases. If you take a short membrane sound, then fundamental frequency will be increases. So, for a woman, since the vocal cord length is shorter, their fundamental frequency is higher. If you see the woman singer, they say the your bass scale is B sharp. What do you mean by B sharp? Average fundamental frequency in the level of the average fundamental frequency. So, if it is woman, then the higher the F0, average F0 will be very high, not compared to male, but for a male, since the vocal cord length is longer, the fundamental frequency is shorter, means average is lower. So, average fundamental frequency for a male is lower than the average fundamental frequency of female. Then filter. So, filter depends on the characteristics of its frequency response. Now, if I say Hs is a transfer function of the filter, if you are electronic students, you know electronics or electrical students, or you know signal processing, then Hs is nothing but a system functions. So, that systems depend on what? System has a property, some pole and 0. So, from there I will define that formant frequency in the next class. So, that is called formant or resonance frequency. Based on the resonant frequency, different sound is produced. I will explain in the next class what do you mean by pole and resonance frequency. So, those is speech, it is called formant. So, in case of woman, since the length of the vocal cord is shorter, the formant frequency is little higher. Longer in case of man, so formant frequency is little lower. So, that is the difference between the male and female speech. If it is child, the fundamental frequency much more higher, because the length of the vocal cord is much shorter, and the formant frequency will be higher because the length of the vocal cord is shorter. So, I can say that formant frequency depends on length of the vocal tract and also other some properties we will discuss later on when we model this vocal tract. So, if the length is increases, the formant frequency will be different. So, I can say if average, if I can say personalize the speech, means my vocal cord or this length of this vocal tract, or you can say the length of this tube may not be exactly equal to other person. So, if it is not equal, then I should have a formant structures which will be different from the other people. So, there may be some information exist from which I can identify the person. So, I can exploit that information to recognize the biometry or biometric signature of the person. Similarly, shows vocal cords, my vocal cords length and weight will be different from somebody else. So, there may be some parameter exist here also by which I can identify the persons. So, biometric signature may be exist in the speech either in filter portion or in source portion, or if I say speech is also depends on the composition of the sound, sometime this composition pattern also provides some information which can be exploited to detect the person. Okay. So, next class I will discuss what is formant, how it is extracted, those things will be discussed. Okay. Thank you.